Hi, I'm Stephen and welcome to Audio Nautica. I know it's been a while since I've been able to do any videos. That's mainly because I moved house, which was very disrupting of course. So I finally got everything unpacked and my new workshop is set up. And I'm getting back to this one-diff QC Symphony board that Harrison sent to me. Now, something that was perhaps not very clear, or certainly wasn't very clear to me on the previous video, is when this whole project started, talking with Harrison, it was originally going to be the one-diff SYM2 QC board. This Symphony board is basically an evolution from the one-diff SYM2 QC board. So what wasn't clear in the previous video was that there's some debugging going on here because this is a new design. So if you were watching very carefully in the previous video, you would have noticed that there was a point where the output signal didn't look quite right. It had some oscillation on it, and I thought at the time that it might have been something to do with just my test setup, which is a little bit rougher and readier than I'd like it to be. And I found that by adjusting the input level, it went away. Well, that didn't really solve anything because it just reduced the input level so that the oscillation wasn't there. So anyway, I pressed on, and when I came to attempt to bias the board, I couldn't bias it. So I've been in discussions with Harrison over the last few months while I've been in the process of packing up, moving and unpacking, and we've come up with a test procedure that will hopefully allow us to nail just exactly what needs to be done to this board just to resolve what hopefully should be a fairly minor issue. But before I dive into that, I just want to show you exactly what this is doing. So I've got the board hooked up. Let's just see if it'll play for me on camera. Put some Lurgatrons on it. And yeah, hopefully you can see that. It's most noticeable on the top half of the positive side of the waveform. You can see that there is this oscillation here, and I've currently got an 8 ohm load on the output. If I remove the 8 ohms, it doesn't make any difference as to whether the 8 ohms is there or not. Okay, so that's what we saw on the previous video. So what I'm going to do now is I'm just going to slightly change my configuration so that it's set up the way that it was set up for when it's biased, and you'll be able to see what it does when we try to bias it, because I think that's quite interesting. This is really important for these debugging procedures because I need to know sort of what the fault condition is, and then I can see as I go through the changes that Harrison has given me, we can see what makes a difference. So I've only got channel 2 enabled on the scope at the moment. Channel 1's still connected to the SIGGEN, but the SIGGEN's not actually connected to the board at the moment, so the input of the board, the inputs are shorted together, and so we're looking at the output of the amp, and there is no load. I think if I add the load in, it makes a little bit of a difference, but change that waveform to see if we can look at it a bit better. Yeah. Anyway, the point is that is not supposed to be there. That's some kind of an oscillation. It's not a huge amplitude. We're on the 0.1 volt per division scale, but watch what happens when I try to bias the board. So on the Keithley up here, this is the bias voltage. So for a bias voltage, we'd want it about notionally 20 millivolts, I think. The procedure says 10 to 20 millivolts. I've actually got 11 millivolts at the moment, which is kind of not too bad, but that's kind of not the point. The point is it's not stable. So let's just see what happens. There, bang. See that? Okay, I'll just wind it down a bit. It's really interesting. Actually, I have to wind it a long way back to actually get it to... There we go. Okay. So I had to do, I don't know, 6 or 7 turns back the other way of the trim pot to adjust the bias to get it to drop back down. So it's 8 millivolts now is the bias voltage. If I start going this way, look at that waveform on the output, it's not meant to be there. And there seems to be a point just about here, 19 millivolts, 20, 21, 22, 25, bang there. All of a sudden, the current has jumped up to 60 millivolts. And now look at this waveform. So the signal counter is saying that that's about 8 meg. The devices start to run kind of hot. Now I have got current limit on the power supply and I've only got 20 volts, plus or minus 20 volts on the rails, so I'm not going to cook it. But it basically goes into runaway, and if I kept on trying to adjust the bias, it just goes crazy. So that's what's going on. If I go back again this way, it's gone. But the point is, well, it's not gone, but the point is that's not meant to be there at all, and then when you bias it up, it just seems to take off and get a whole lot worse. So this actually seems to be fairly reproducible. So just take the power off the board. That gives me a starting point. Oh, just very quickly, while it was in that state, to see what happens when we put the load on it. Doesn't make a huge difference. It does affect the signal, I guess, as one would expect. But yeah, so I think that gives us a reference point for me to be now able to dive into this procedure that Harrison has given me and see where we go from there. Okay guys, so step 1 in the procedure was to remove Q5 and Q10, which is basically half of the output drivers. I think from memory they're more or less in parallel. So they're the same device. There's 4 of them in total. And I've removed half of them. And I noticed that that strange oscillation now seems to be gone, and the biasing behavior seems to be much more like what I'd expect. So you can see, if we look again at the Keithley, this is the bias voltage, and as I increase the bias, it just seems to linearly go up without any strange jumps, and there's no weird oscillations or anything on the output like there were before. So that is step 1. Okay guys, so I've been in conversation with Harrison. It's just to refine our test procedure for our findings. So I have got all of the final transistors back in place now, and the next stage was just to add a capacitor across one of the resistors just to see if it's a phase shift oscillation. And whilst it has slightly changed the waveform, again I think we'll see the same kind of behavior as I wind again here's the bias voltage here, wind this up through 20 millivolts, 25 millivolts or so, which you get up to about, yeah, we got to about 35, then bang, it just took off. Now the waveform is slightly different. It was a perfect sine wave before, but aside from that, the behavior is more or less the same, and then I have to wind the bias all the way back, a long way, and bang, it drops down to about 5 millivolts. So that I think was a worthwhile little test. but no, it has not resolved the problem, so we need to move on to the next step. Okay guys, so we've been through a few steps. I haven't shown you them all on camera because they got a little bit fiddly, but I think that we've made some progress. So essentially, the only thing that is different from the original configuration now is that there are 100 ohm series resistors on the bases of the 4 drive transistors, which is a bit of a pain sort of logistically to get that done because of having to cut tracks and shove things in there. I've got this channel, this little bit of L bracket aluminium channel back on just to help with just a bit of heat dissipation while we're testing here. But there's no sign of that oscillation that was there at the moment. So I've got the bias is currently sitting at about 10 millivolts, and I've found that the bias adjustment seems to behave as I would expect. So I can wind it up, and like before we had an oscillation even now, and then it started to take off about here. Well, there's no sign of any oscillation, there's no sign of taking off, and I can quite happily wind the bias back down to about 10 millivolts. And that's the kind of behavior that I would expect. Okay, so I'm just going to hook up a signal to this thing now, and we'll just check that the signal looks kind of as we would expect. Okay, so there we are. So we've got a 1 kilohertz input, and we can see that we have a nice sinusoidal output as we would expect. Yeah, that looks pretty good. And now, if we just change this to square wave, just this roll off here is not quite as sharp as I would expect it to be. Let's just go back to here. Go to 100 kilohertz. Looks pretty good on sine wave. We get a square wave. I mean, I know we're well out of our audio range now, but even so, drop back to, just bring it up to, let's go to sine, and just bring it up to 20 kilohertz is probably a good place to be. 25, that'll do. Okay, square wave. I just would have thought this would be a little bit sharper on these transitions here, so that might be something to have a look at. But anyway, we call this progress, I think, because before we were having all sorts of problems, and so this is certainly looking much better. So I'll report this back to Harrison and see where we go from here. Okay guys, I'm just going to wrap up this debugging video. I've been in contact with Harrison again, and I've just done a few little other changes off camera as well, just to test various configurations, just to see whether they make any difference, and they did not make any difference. So basically what we are back to having now is we have the 100 ohm series resistors in the bases, and then on 2 of the bases on each side there's a 1 nano film capacitor. So that's this guy sort of down here that you can just see. That didn't seem to make any difference either, as far as I could tell, but it's something that Harrison asked me to try. Anyway, the point is there's no sign of that oscillation problem that we were having before, so that's good. So I'm going to wrap up this debugging test video on this SYMPHONY amplifier board. There will hopefully be subsequent videos, so please do make sure that you subscribe to my channel so that you know when I put up more videos. Thanks so much for watching. I hope you enjoyed it. Give me a like. You can support me over at Patreon, patreon.com/AudioNautica, and I really look forward to seeing you on the next video. Bye for now.